Welcome to section 410, Antiderivatives. This is an exciting section because it is the gateway into integral calculus. So calculus is typically divided into two parts, differential and integral. Differential is what we spend most of the time in Math 1A doing, taking derivatives. In Math 1B next semester, which I hope you'll all be in, we're going to spend all of our time integrating, which is finding antiderivatives. So just a little warning, your homework's pretty long, so give yourself plenty of time to do that. First, a couple definitions. An antiderivative, big F is an antiderivative for little f. If you take the derivative of big F and you get little f. For example, all of these functions here have derivative 2x plus 3. So they're all antiderivatives of 2x plus 3. Because the derivative of 7 is 0, and the derivative of negative 5 is 0. So notice that there are many antiderivatives of 2x plus 3. There are 3 right there. In fact, if I added on any constant, that would be an antiderivative of 2x plus 3. So we have a name for the set of all antiderivatives, and we call it the indefinite integral. And it's the set of all antiderivatives of little f. And so the notation is this squiggly sign, which is like it's called an integral sign. So the integral of little f of x dx, dx is called the differential, and it tells you what variable you're integrating with respect to. And that's equal to big F of x plus c, where big F is any single antiderivative. So let's look at an example. I claim that the integral of cos 2x dx is 1/2 sine 2x plus c. The check would be, is the derivative of this function here the integrand? Cos 2x is called the integrand. Okay, so let's take the derivative. 1/2 is a constant. When we take the derivative of sine 2x, by the chain rule, we bring out a 2, and then cos, and we leave the inside alone, and then the derivative of c is 0. And the 1/2 cancels with the 2 to give us the integrand cos 2x. That's what we have here. So yes, that is the integral of cos 2x dx. Now notice, when we take derivatives, we had a formula for the derivative, let's say derivative of sine kx prime is k cos kx, because by the chain rule, take the derivative of the outside function, which is cosine, leave the inside alone, and then multiply by the derivative of the inside, which is k. Here k is a constant. When we integrate, instead of a k coming out, a 1 over k comes out. And so let me just jump ahead to the integral Bible. Notice that all of these integrals, aside from the plus or minus, have a 1 over k in front, all the trig functions. And that's because when you take the derivative, using the chain rule, a k comes out. And so that 1 over k cancels with the k that comes out when you take the derivative. Okay, and so that's what just happened up here. Okay, never write an integral sign without the differential. And students get a little bit sloppy and they'll do that, okay? And I'm going to be really hard on you. Think of these as parentheses. You would never, ever in English see just one parenthesis, right? Well, maybe you would, but I don't think so, not that I'm aware of. They always come in pairs. Integral signs always come with differentials. And the nice thing is, you're supposed to integrate everything in between. They're like bookends. So let's see what happens if I move the differential around. All right, so I'm going to do this by inspection. I'm going to say, okay, what function has derivative 4x cubed minus 2x plus 1? Well, x to the 4th seems like a reasonable start, because when I take the derivative of that, I'll get 4x cubed. Then a minus sign, and maybe x squared, because when I take the derivative of x squared, I get 2x. That's looking good. And then a plus sign. And what function has derivative 1? X does. So there is my integral. Then I add a constant on. So x to the 4th minus x squared plus x plus c. And I did that just by inspection. Okay, what if I move that dx over here and then add 1 later? Okay, so now I'm supposed to integrate 4x cubed minus 2x and then add 1. So what I get is x to the 4th minus x squared plus c, then plus 1. And since c is a constant, I could just rewrite that as x to the 4th minus x squared plus d, where d is another constant. So that's a different answer. So moving the differential changed our answer. Next one's a little bit tricky. See if you can do it without me. Just pause the video and see if you can get it. Okay, if you got x cubed t plus c, give yourself a pat on the back. If you didn't, don't beat yourself up. Integrating with respect to t means x cubed is a constant. That could be 5 cubed or pi cubed. Whatever it is, it's a constant. And we know that if we multiply a constant by t and then take the derivative will just be that constant. Okay, now this last one is a guillotine. It doesn't make any sense to have an integral with no differential. There's no differential there. So very bad, just don't do that. You know what happens at the guillotine. Okay, properties of indefinite integrals. Since integrals are antiderivatives, they behave like derivatives in that if you want to find the integral of the sum or difference of two functions, you can just find the integral of one and add or subtract the integral of the other. Now, I did that up here. I did that. I wanted an antiderivative for that, x to the fourth, and an antiderivative for x squared. I did that. So I did it piece by piece. So I was actually using that rule without you even knowing it. But it seemed to make sense, right? Because when we took the derivative, we got the right thing. Same with constants. Constants can come out of integral signs. But just like derivatives, you cannot integrate a product and get the product of the integrals. For example, the integral of x times x plus 1 dx is not going to be the integral of x dx times the integral of x plus 1 dx. Just like the derivative of x times x plus 1 is not the derivative of x times the derivative of x plus 1. We have the product rule for products, right? We have something similar for integrals, but we're not going to learn that for a while. So just be careful. You still could find this integral at this point in your life. You would just have to distribute x squared plus x dx. And then you could actually find an antiderivative just by doing inspection. So that is actually what we call, that's an example, what I did there, of this, which is the power rule. That's how we integrate powers. The integral of x to the n dx is 1 over n plus 1 x to the n plus 1, as long as n is not equal to negative 1. The n equal negative 1 case is this. It would be the integral of 1 over x dx, and that's natural log of the absolute value of x. You have to memorize every single integral in this Bible. The light blue ones we'll cover later, but for now, you need to memorize this. And some of it's just inspection and some of it just makes sense. For example, why is this true? Well, we know that the derivative of tangent is secant squared, right? And so the 1 over k comes out because when we take the derivative of this, a k will come out. And so this is just working with derivatives backwards. Notice that e has its own special rule. If we take the derivative of e to the 5x, we get e to the 5x, and then in front we multiply by the derivative of the exponent, which is 5. And so if we want to integrate e to the 5x, this is going to be almost the same, but it's 1/5 e to the 5x plus c. Okay, so let's practice using some of these Bible formulas. Okay, find a general antiderivative for this function. This is in English how to state it. Find a general antiderivative for f. But in math, we would say, okay, find the integral of f of x dx. It's a quicker way to say it, right? And so that's going to be equal to, not arrow or anything, this is good old equal. We're going to find an integral for 2x cubed using the power rule, okay? So the 2 is a constant. It just carries along. The integral of x cubed using the power rule is 1/4 x to the 4th, okay? Then 3 is a constant. The integral of x squared is 1/3 x cubed plus. This is x to the 1. So by the power rule, that would be 1/2 x squared. And then 7, a function that has derivative 7 would be 7x. And then plus c. And then clean that up. That's 1/2 x to the 4th plus x cubed plus 1/2 x squared minus 7x plus c. Now in reality, when you do this, you're going to do the whole thing in your head and you're going to go straight to that answer. Because you're going to look at this and say, okay, 2 times a 4th is 1/2. So you don't have to do this intermediate step. I'm doing that so you can see how I got my answer. Okay, Just like derivatives, oftentimes you have to rewrite a problem. Oh, this is A again, 2 A's, I guess. You have to rewrite a problem before you can use the appropriate rule. So if I want to use the power rule on this, I need to rewrite it. So this is equal to, I still need the integral sign because I haven't integrated. So you drop the integral sign when you actually find an antiderivative. So this is negative 5x to the negative 3 plus 6x to the 1/2 dx. So that tells the reader I'm just rewriting, I haven't done the integral. Now I'm going to drop the integral sign because I'm going to integrate. So drop the integral, drop the dx, put your answer plus c, okay? So let's do this mentally. Add 1 to negative 3 to get negative 2. Negative 5 over negative 2 is 5/2. Our new exponent is negative 2. Okay, then we're going to go plus 6 times, I'll do this one slowly. So add 1 to 1/2 to get 3/2. Flip 3/2 because 1 over 3/2 is 2/3. So when you have a fraction, 1 over a fraction, when you're integrating, you're going to have 1 over a lot of fractions. So I'm skipping right from here, 1 over 3/2 to 2/3. So that's what I did there. X to the 3/2 plus c. So let's rewrite that. That's 5/2 x to the negative 2. And then 3 goes into 6 twice. 2 times 2 is 4. 4x to the 3/2 plus c. If you're not sure if you did it right, take the derivative. The derivative of your answer should be the integrand. Okay, next one, straight up Bible formula. Cosecant, cotangent. I know the derivative of cosecant is negative cosecant cotangent. So this is going to be equal. First of all, there's going to be a negative and a 1/3, and then a cosecant 3x plus c. So that's straight up. I did it using just thinking of differentiation backwards. But if you're not comfortable with that, Bible formula right there. So all these formulas would be good candidates for flashcards. There's some flashcards online for integrals, but I think the value for me in a flashcard is making it. And so I think it's more helpful to make one than actually use one. Okay, next one is, again, just two Bible formulas together. This is equal to the integral of e to the 4x. Instead of a 4 coming down, a 1/4 comes down. Plus ln absolute x plus c. Don't forget the absolute value. Okay, initial value problems. These are integrals in disguise, and you have to do two things. You have to find the function and find c. And you can find c using the initial condition that you're given. You're usually given like y of x naught is y naught, and that will allow you to determine c. So there's 3 steps. 1, find y by integrating y prime. 2, find c. 3, put 1 and 2 together. Plug c back into your answer. So let's try it. So we want to solve this initial value problem. So step 1, we're given the derivative. So the way to find the function, the way to undo the derivative is to integrate. And you do need to name it y. Just don't write just that, because this function needs a name. Y equals 3x to the negative 2/3 dx. Okay, now we're going to evaluate this integral. Add 1 to negative 2/3. Negative 2/3 plus 1 is 1/3. 3, we'll do the scrap work over here. I have 3 times 1 over 1/3, which is 3 times 3, which is 9. 9x to the 1/3 plus c. Okay, so that's step 1. Step 2, find c. Y of negative 1 is 5. So where you see a y, this is y, put in a 5. And wherever you see an x, put in a negative 1. Okay, the cube root of negative 1 is negative 1. So 5 equals negative 9 plus c. Add 9 to both sides. That implies c must be 14. Okay, step 3, take that c, put it back in here. So your final answer will be a function. Y equals 9x to the 1/3 plus 14. So your answer is a function y equals. That's why you need to have that y equals there. Find a curve whose slope at xy is this. And so if the curve is y equals f of x, we're told that this is y prime. And then this information, another way to state this would be y of 1 is pi. So sometimes the information is given to you in a different form. So this is an initial value problem. It's just kind of in code. All right, so step 1, y is the integral of y prime. Okay, so this is one of those special formulas at the end of the Bible. You should recognize a function whose derivative is this. It's sine inverse of x plus c. The derivative of arcsine is this. Remember, let me just come up here in case you're a little confused. Sine inverse of u of x prime is u prime over the square root of 1 minus u squared. Well, if your u is just x, u prime is 1, and this is 1 minus x squared. Okay, step 2, let's find c. So put pi in for y and 1 in for x. Sine inverse of 1 plus c. Now, sine inverse of 1 is pi over 2, because sine of pi over 2 is 1. So pi equals pi over 2 plus c. So solve for c, subtract pi over 2 from both sides. That gives us c is pi over 2. And finally, step 3 is just to put 1 and 2 together. Y equals sine inverse of x plus pi over 2. There's our curve. Okay, this one I like because it reinforces our knowledge of how exponentials and logarithms pair up. So let's start it out. Step 1. Actually, maybe you should pause the video, try it yourself, and see if you get the right answer. Okay, hopefully you did that. Here, instead of y, we're told f prime, so I'll call my function f, or f of x, is the integral of 6e to the negative 2x dx. All right, Bible formula, negative 1/2 comes out and multiplies by the 6. So 6 over negative 2 is negative 3 plus c. Okay, that's f of x. So step 2, put 1 in for f of x and ln 3 in for x. Now, e and natural log are inverses. However, before you can cancel the e and the ln, that negative 2 needs to go away. And the way it goes away is it comes up as an exponent. So let me do that over here in my scrap work. E to the negative 2 ln 3 is e to the ln of 3 to the negative 2. 3 to the negative 2 is a ninth, okay? So now these guys cancel. E to the ln of 1/9 is 1/9. All right, so over here I get 1 equals negative 3 times a ninth plus c. So c is 4/3. Okay, and step 3, f of x, our original function, is negative 3 e to the negative 2x plus 4/3. Okay, we're almost done. If we're given acceleration, how do we find velocity and position? So I want to remind you, if we're given position, s, if we take the derivative, we get the velocity, right? So that means if we want the position, we can integrate the velocity. So those formulas come in pairs. And if we take the derivative of velocity, we get acceleration. So if we have acceleration and we want velocity, we can integrate acceleration. Okay, so we're given that acceleration is 6t plus 14, and we're given some initial conditions. First, we want to find the velocity and the position functions. So A, the velocity, is going to be the integral of the acceleration, which is the integral, A is 6t plus 14, dt. My differential is dt. Okay, so now use the power rule. The integral of t is 1/2 t squared. 1/2 times 6 is 3. So 3t squared plus, this is a 14, so 14t plus c. Now, I want to find c. So I'm going to use this initial condition, the one that involves velocity. So put 4 in for v and 0 in for t. So I get 0 plus c. So c is 4. So now I know my velocity is 3t squared plus 14t plus 4. So circle that. It's part of our answer. And now to find position, we're going to integrate that. So you have to go backwards in steps. S of t is the integral of v of t, which is the integral of that, 3t squared plus 14t plus 4 dt. Okay, and that's t cubed plus 7t squared, and then plus 4t plus c. Now this c is different than that one. You could call it d if you want, but since we've already found that c to be 4, there's no problem calling this c again. Now we're going to use the other initial condition that s of 1 is 0. So be careful here. S is 0 when t is 1. So I'm putting 1 in for t. 1 plus 7 plus 4 plus c. So that gives me c is negative 12. So my s of t is, I go up here and I put negative 12 in for c. T cubed plus 7t squared plus 4t minus 12. So that's the other part of the answer. And then the last part's actually the easiest. Part B says, what is the position at t equal 2? So what they're asking for is just to find s of 2. That's all they want. Position at 2. So s of 2, 2 cubed is 8. 2 squared is 4. 4 times 7 is 28. Plus 8 minus 12 is 32. So the real work is doing A and B. Okay, and so that is the end of this section. I left this off on your lecture notes, so don't worry about that. I think you're going to have your hands full just doing your homework. There are a lot of problems, and they're pretty important. And I also want you to memorize your integration Bible. Okay, and that's the end of this section.